Morning, guys. So, in our last session, we have discussed about some services like Cloud9 CDK. So, I hope you got some time to deploy that Lambda scripts, and I will. I forgot to share the Cloud Formation script. I will upload that to our uh, GitHub, or else I'll share along with the material I want to share. So now. When coming to the remaining topics, so here we are going to discuss about what exactly continuous integration and continuous deployment in AWS. And I hope you guys are registered to the Jenkins course which I shared. So if not, please drop an message now. I'll generate a coupon at end of the session and I'm going to share that. If you already registered, yes, please go through that coupon. So you are like you know you can understand what exactly DevOps culture and how it took the market and what are the tools, some common tools we using. So those all things I have explained in that uh, Jenkins course, right? So whoever is not registered, please drop a message in our chat box. Yes. Browser. So here I'm logged into my AWS account, and when coming to this CI/CD, so CI/CD stands for continuous integration and continuous deployment or delivery. Okay, so here I logged into my AWS account. So when coming to the CI/CD, so commonly we are going to use some tools. So we are going to basically when coming to the mechanism. So generally, multiple developers they are going to develop their code, and end of the day, they are going to commit all those changes to a central repository. So within this place, we are going to use Git. So we can use Git and or else TFS, Team Foundation Server, or GitHub, or Tortoise SVN, right? So many repository tools are there. So we are going to choose one of the tool. So then end of the day, we followed the nightly build process. So end of the day, one application admin is going to take all the code. He is going to prepare a build where he is going to give a proper format to deploy that file into that in one of the server to deliver that. So he is going to prepare a build and he is going to deploy that to one of the server, whatever the build he prepared. Well, this server is going to be initially it's going to be internal facing. So only internal testers and all they're going to test that. So then they will make it available for prod environment. Production means all the end customers, they are also going to access this server. So this is the process. So when coming to AWS CI/CD tools for this repository, we have AWS code commit. Whatever the tools you use for Git, same tools we can use it with this code commit. Build. When coming to this build, so Amazon have its own tool that is a code build. So in this phase, you can implement Jenkins, Maven, or and such type of tools you can implement and you can prepare the build. So Maven is some widely used one. So in the given course, I took Maven to explain this stage, right? So then we can deploy it. So you can take an EC2 instance. So that EC2 instance I have taken in that our course. right? So here we can take elastic bean stack, we can deploy it like, elastic container service. So we can deploy it. So then we can make it available in between. If you want to add additional like stages, like a manual approval and also definitely we can implement that also here. So now I'm going to perform this continuous integration and continuous deployment by using these tools. So to automate this entire process, generally we are going to use Jenkins, but here I'm going to use code pipeline. I'm using code pipeline. I'm using code pipeline. So then by using this pipeline, this process is going to automate it. So whenever any developer commit any changes to this repo, this process is going to happen automatically. Earlier, so one of the user need to take this code and is going to prepare a build and is going to deploy at end of the day. If any bug comes, so we need to that bug comes in this phase. So then they are going to inform to this developer again. So in next release, we are going to fix that bug and we are going to commit the changes and also again the process is going to happen. But the same process got automated and whenever this guy commit any code, this pipeline is going to trigger instead of nightly build. Instead of daily one time, this pipeline is going to run whenever any developer commit any changes. So how system is going to recognize what changes is happening on this repo? So we have CloudWatch. So this CloudWatch will keep on monitoring, okay, where is our code? What changes happening on our code? It will keep on monitoring those things. So then when something happened, it is going to trigger the pipeline. So in place of this code commit, we can even to Git also to perform this. So now I'm going to use code pipeline. I'm going to use code commit and I'm going to skip this build stage as I'm going to pick some PHP code. Then I'm going to deploy this code to Elastic Beanstalk environment. Then I'm going to deliver to end customer. Right. So again, I'm going to perform some modifications to the code and I'm going to commit to the repo. So then either it is an S3 bucket or code commit, whatever it is. So whenever any changes happen to this repo, so then it is going to happen, the process, it's going to happen again, right? So this is a continuous process. Now, first of all, if you want to use this code commit from your local machine, first of all, you need to install Git in your local machine. So whenever you go to this browser and when you get git download, so here we have git-scm.com/downloads is a page. So you can choose your operating system platform. So then you can download that client and you can install that in your local machine. Right. So once you're done with this installation, so then you can go and you can open your command prompt and you can give git-version. So it should return with the what Git version is installed in this machine. If it is saying it is not recognized command and all, that installation is not succeeded, you need to reboot that machine. So this is a page where you can download this Git as a first step. So then after, we can create a repository in AWS and we can get that all code and all to our local machine. For that, click on code commit. So you can use Visual Studio Code for easy integrations and all. So now I want to create a repository. So it's pretty straightforward. What repository you want to create? Click on create repository. What is a repository name? So Avinash repo, or let me give CI/CD repo. I'm going to call this as a CI/CD repo. Scroll down, click on create. So in GitHub, how exactly we have Git Git commands like git commit, git pull, git push. What exactly those commands we have? Similar commands we can use it here, right? So now we got this repo. How to get connected to the repo from our local machine? For example, I am going to take a folder. Let me take a folder. local repo. So I even shared the entire Git course, guys. So if you haven't registered, please mention that. So it's just like 1 hour or 1.5 hour course where you can understand what exactly Git and what are all the commands. Now you can go here and you can download all the prerequisite softwares here. Then you can do that. So otherwise you can directly use HTTPS connection. First of all, you need to have Git credentials. So we need to download the Git credentials and we need to store that. So whenever you are using this particular one, when you copy this, then you can give that command in the Git repo location, then it is going to. So what you can do, you can create an IAM user. So here, learn how to create and configure an IAM user for accessing code commit. So here, like an article where you can create an IAM user. So add permissions. You need to grant permission. You can choose attach existing policy directly. So what permission you can give? AWS code commit power user. So this is a policy that user required, and then you can go and you can configure CLI. So then we need to install the Git repo. So then we can follow this. So we can go and we can generate HTTPS Git credentials for AWS code commit. Then you can store that, you can download that, and you can configure. So then once that is completed, whenever you are giving this command in your path, it is going to. So now let me create an IAM user. So basically in my project, we use SSO. So that also I'm going to explain. But I need someone who can volunteer for some time, to share their account details, and I'm going to add that account to organization. If you guys are ready, so then definitely I'm going to explain that. Okay. Um, Repo user, I'm going to pick programmatic access, permissions, and I'm going to give code commit full access or code commit power user also you can take. Review, create user. So now let me take a command prompt, AWS space configure. So then we need to provide the access key ID. Come on, I cannot click on enter also. It's going to take an empty slot for the first one if I click enter. So we need to wait till that give response. I don't know what happened to my Windows machine when it got updated. So from that time onwards, it's behaving weird. Let me copy this, pasted, secret access key, copied. So then default region episode 1, default output format none. Okay. So now I want to clone this repo. So for that, let me go inside this location. So now I'm under local repo. So then I want to clone this to my local machine. We can pick this and we can give this. So now it is cloning into this repo. So earlier we don't have anything, but now you just observe CI/CD repo. It got created. We have .git folder. So now always, if you want to commit something to this, so you need to work on this particular location. So all the changes you can perform in this local repo, then you can commit that changes to AWS environment. So that is a mechanism, right? So it is cloning. When it got completed, we can see. So now let me go inside the cicd.repo and let me open the command prompt. And we have some commonly used commands like, git status. Git status. It tells us like, in what branch we are currently, do we have any files like, that got created and where we can commit all those files and all. At moment, do we have any files here in this repository? No files, nothing available here. So, but in my local machine, I can create a sample file. So sample code, then when I create this file, so this is my sample file. So I created a sample file in my local machine. So now after this, I'm going to give same command git status. Then it is not going to give same again. See, we have a file that is untracked where it is in our local machine. So what we need to do, we need to track this file initial stage. To track that file, we need to use git add whatever the files. Now always give this command, guys, git status. It tells you what exactly. Earlier it is untracked file. It is an untracked file. The git is not tracking this file, but a new file got created. Okay, now what I'm doing, okay, whatever the files you have, track all those files. So I have given git add. Now when I give git status, okay, there is a file with this name. Now do you want to commit this file? So the system will remember and it is ready to push that file. So now for that the command is git commit hyphen, what is the commit message you want to give. So I'm going to call this as a first commit. I'm going to give first commit, click on enter. Now one file got changed, one insertion happened. So this is the commit code and this is a commit message. So now this is a file we are committing. Fine. So now if you are giving git status, nothing. So we have a file that git already remembered that file. Now, do you want to commit that file to this AWS repository? So if yes, then you need to give git push command. Go here, git push, click on enter. So now we need to push, we need to set an upstream, that is origin to master. Simple, copy this command, enter that here, click on enter. So then it is asking for username and password. Oh, come on. We need to give the grid credentials here. So navigate to my security credentials. And here code commit credentials. HTTPS grid credentials for AWS code commit, generate the credentials. So this is a username, this is a password. Now, when that comes, yeah, go and shit. I'm resetting the password. Okay, so here is a username. Here is a password. Whenever we give that username and password, so those code is going to commit here. See, this is a file. So basically where this file got created, it got created in my local machine. So by using this mechanism, I have pushed. So from now onwards, if I want to perform something, I can do in my local, machine and all. So test file, I've written something. Now this file I want to commit to code. So basically this repository, multiple team is going to work on this and they can create some branches, they can perform some commits. Okay. So now I want to track that. So again, simple git status. One thing, whether you are in the right path or not. So then it is taking untracked file. Then what is the command? Git add this particular location. So then again give git status. Okay, so then give git commit. What is the commit message you want to give? Test123 is a commit message. It got committed. Now if you give git status, nothing. So now we need to push this. These changes got created in our local machine. I want to push these changes to my central repo. So for that, navigate here, git push, enter. So then see, it is going to give upstream automatically. Otherwise, we already given that upstream earlier. So it is going to pick automatically and see that that file also came here. Even can we delete this file from this location? No, we don't have any option to delete this file. If you want to delete, you need to delete it from local machine. For example, I want to delete this test file.txt. For that, I'm going to remove test file.txt. So rm is not a command. So what is a command? Okay, I'm going to delete manually. So now I have deleted that file. So if I go here, if I give git status, one file got deleted. So do you want to delete this file from central repo also? Then give git add dot git commit -m removed file. So then give git push. So now whenever we go here, when we give refresh, that file got deleted. So if you want to perform this type of options, we need to do from this only, right? So now sometimes another developer, he performed his changes and all, he committed all those changes here. But your machine is not up to date. For example, I'm going to add a file manually. So that means let's assume someone already did that. Someone did that. So the author is Avinash and Avinash commit changes. So now, so this file got created here. But do I have that file in my local machine? Did I have that? No, right? Multiple developers. Let's assume that is uploaded by some other developer. I want to keep that in my local machine. For that, simple. Go here, observe git status. It tells us, okay, whether we are ahead of that existing repository or we are back. So that will show us, mm, it should show up to date origin master, nothing to commit. So now we can give a command called git pull. Push is to push changes from your local machine to central one. Pull is to get all the changes happen on from this machine to your local. Earlier, do we have the EC2 answers file here? No, right? But now I'm going to pull. When I gave git pull, see total objects 3 and it got the file called EC2 answers from the repository to my local machine. See this, the file came. So these are some common commands, guys. If you know these commands, you are good with the git. Okay, so same command. See, I'm explaining this with the AWS code commit. Same commands you can use. So to clone, git clone https:// code commit URL. Okay, that's the first one. So then git add, this is going to track the changes. You can always use git status command to know the status. Git commit -m, what is the commit message you are giving? So then git push is to push the changes from your local machine to central one. So then if you want to git push -set -upstream origin to something, but this is not really required. Even whenever you are trying to give git push command, no, it is going to show you. So then if you want to, you can use git pull. Get changes from central repo to local repo. File changes. Tells you the status of the file. Commit the message to local git. Push the code to central repo. So these are the commands. But how to connect? First, create an IAM user, allocate required code commit permissions, and then generate HTTPS code commit credentials, configure CLI user. Whenever you are when pushing the code, enter the credentials generated, then you are connected to that. This is a connectivity process. Now in my local, I have some sample PHP code. Whatever the PHP data I have, I'm going to see these all are the data I'm going to use. So this particular git I'm not going to use. I'm going to copy everything and I'm going to paste it here. So this EC2 answers and sample code I'm removing. Now what I'm doing here, I'm giving it status. It is going to show you, okay, these two files got deleted in the there and these all are the files got added. So now I want to commit all this code to my repository. Simple git commit -m added PHP code. Okay, git add git commit, right? So now so after this git push. So these all files came to my repository. So this is all the files. These all files came to my repository. Okay. So now I'm going to use this code whenever this developer commit any changes to this repository. So a pipeline need to trigger automatically and this code need to deploy. Okay. So that is what I want to configure. So for that, I'm going to use a pipeline. Navigate to pipelines, create a pipeline. What is the pipeline name? So CI/CD pipeline is the name I'm giving. So I'm going to create a new service role for this operation. Then click on next. Now, what is the source? Where is your code? So that we need to give here. Before that, let me do one thing. We need something to deploy. Let me create an elastic beanstalk where this code is going to create and it need to deploy it, right? So create application name, CACD app, and it is, I'm going to choose PHP. Why? Because my code is in PHP. Then I'm going with sample application, create application. Okay. So it is creating. So now meanwhile, so where is your code? So my code is in code commit. I can go here in what repository? This is my repository. In what branch? My code is in master branch. Now, how you want to detect any changes on this repository? So we can use code pipeline, but this is not an intelligent one, guys. So periodically for every 5 minutes, it will go and it will check. For every 10 minutes, it will go and it will check. But whenever you're picking this Amazon CloudWatch events, It is an intelligent one. Automatically it will detect, and whenever it detect any changes happening on our repo, it is going to trigger that, like, so this is a suggested one to go and choose. So I'm going to pick the same one, then click on next. Who is your build provider? If you want to use, we can add Jenkins. So what is Jenkins server URL and all, we can use that, or else we can use code build also. So, but as this is a PHP code, I'm going to skip the build. So skip build stage. Now, this is a deploy. Where do you want to deploy? So I want to deploy this to an EC2 instance, or I want to deploy to cloud formation. I want to deploy to, like, code deploy, right? We have multiple options. So I'm going to choose Elastic Beanstalk. So where that Beanstalk environment is running, it's in Mumbai region. And what is the environment name? So once this got ready, we can go and we can pick the CI/CD app, and the environment is CI/CD app environment. Now, before that, my environment is going to give a basic output, like, um, a Beanstalk sample web page we are going to get. So, but when it got completed, instance deployment completed successfully. So that's almost a final stage. So in a minute or two, this environment is going to be up and running. Right here we can see this environment is up and running. So this is the URL. So whenever we click on this URL, we are getting this page, default page. Now, whatever the code I developed and I have committed, that need to be deployed here in this PHP, right? So for that, I'm using this pipeline, then click on next, scroll down, click on create pipeline. Now pipeline got run and it picked the code from the source, that is nothing but our code commit. Then it is going to deploy that code into Elastic Beanstalk. This is what our web page so far. After some time, what code we developed in our local machine, this is a code. This is a code, right? So this code is going to deploy there. So let's see whether we'll be successful or we'll land into any issues. So the deployment is happening now. Some issues with this from my local repo. That causing an issue. So now I'm performing some changes on my code. So now those changes are going to be committed here, where under this repository, that zip file is going to delete this zip file. When this got successfully deleted, so now the zip file got deleted, not yet deleted. Git commit, git push. So now it's going to delete from the local repo also. Whenever any changes happen on this local repo, so then this pipeline is going to trigger again. It is in progress. Why it is in progress? We deleted something. So just now again it is going to happen. So then again it is going to deploy here. See this, that zip file caused the issue. So see here, it got deployed and it is able to. For example, I want to change this. Instead of this congratulations, I want to modify something. So where I'm doing, in my local machine I'm doing. So I'm going to edit this in my local machine. Come on. I'm editing this in my local machine. So instead of congratulations, I'm going to give updated deployment. I'm going to write it as a updated deployment. Oh, come on. Okay. So this is updated deployment. I did my changes in my local machine. So here if I go and if I did git status, this file got modified. So then what I need to do? Git add git commit -m latest code. So then once it got completed, I need to push these changes. So now this repository is going to take the changes. See here the deployment happened 1 minute ago. But now if I came and if I gave refresh, so it is going to pick the changes. See here in progress. See, I did the changes in my local machine. This pipeline is triggering automatically. And the same thing we are going to get here in a minute or two. In between, if you want to add any of the manual approval stages or testing stages like blaze meter or ghost UI testing, if you want to add such type of testing, we can do that here. So now let me go and let me edit this pipeline. Click on edit the pipeline. I want to add a stage in between. Whenever this guy commit any changes, so automatically the changes need to be approved in between, then only it need to deploy. So click on add stage. Manual approval is the stage name I'm giving. Add action group. Given name, so manual approval, or you want to add any of the stage here, we can pick any of the stage. We have many testing also blaze meter, ghost inspector UI, we can pick any of the one. So I'm going to give manual approval. So what is the SNS topic you want to give? EC2 notification SNS topic. Scroll down, done. Scroll down, click on save. Now see, here we got the latest changes. This is an updated deployment. Those changes happened again. So now I have added manual approval. Let's see how exactly that works. So now I'm going to, this is an updated deployment with manual approval. So I have saved this file. So now if I go and if I give git status, again that file got modified. Git add, I'm going to track the changes. Git status, it tells you the status. Git commit -m added manual stage. Then so this commit message, we can easily understand what changes happening in our code and all. I will show you where you can find git push. So now we have committed those changes. Now this is going to detect the changes again, and whoever is subscribed to the SNS topic, they are going to get the notifications. So the pipeline got triggered just now. It analyzed our changes. Now where it got pending, it is pending at manual approval. So either you need to review here, or whoever have valid SNS topic permissions, see this EC2 notification. The following approval action is waiting for your code pipeline for action user 1. So now you can click on this, you can review the changes. If you approve, then it is going to deploy. If you don't approve, it is going to stop there itself. So now it is loading. So click this review. So we can find what is the comments about this action, what is the comment you want to give, approved or rejected. If you reject, it is not going to deploy. If you approve, yes, it's going to. So click on approve. Then only as we have approved, then it is going to deploy. If you reject, it won't come here. So now this is the latest code. So in a minute or two, we are going to get that the latest one. See here, there is an updated deployment with manual approval. All the things we are performing from our local machine. So as a source control, we are using Amazon code commit. Then we are using pipeline and we are using Elastic Beanstalk and we are deploying. So this is an example, how we can use this code commit. So basically, it is free to use code commit free tier eligibility. So I think one repository is free. First 5 active users, it's going to be free. Unlimited repository, 50 GB month of storage, 1000 git request per month. But after that, for every repository, we are going to get charged with this, right? Anyone with AWS account can get started with AWS code commit for free. Your account gets 5 active users per month for free. Okay, so then after we are going to get charged, right? So you can you are the only one who is going to use that repository, so you can create you can use and you can definitely unlimited repositories you can create. So that is a free tier limitation. So these credentials are important while configuring, right? I'm going to delete. So any questions on this process, guys? So the Git complete course I already shared, Jenkins complete course I already shared. So please spare some time and please go through those courses, guys. Okay, so now when coming to another thing, so that is the latest mechanism, that is a containerization mechanism. When coming to the containerization mechanism, um, Amazon have its own containerization tool, just like Lambda. So that tool name is AWS Fargate. So when coming to this AWS Fargate, it works within a service called ECR, and ECS. So basically, ECR is a place where we can store all the repositories. Elastic Container Repository. So this is for developers how exactly we have Git. So similarly, this is Git version of containers. How exactly you are storing code in Git, and similarly containerized images and all we can store in this ECR. So when coming to ECS, Elastic Container Service. So we can use this ECS, Elastic Container Service, and we can whatever the images you are storing here, we can deploy here it in ECS. So to connect to this ECR also we have a couple of commands. So where we can deploy that here. So what is this containerization mechanism? See, I'll explain you. In simple terms, earlier we used to have only one server, and that server, on top of that, we are going to use one operating system. Then you are going to deploy your application and you are going to deliver that application. So is this application small or big? That doesn't matter. You need to have a server, and this OS is going to take a lot of resource and it is going to deliver, right? But later on, what mechanism we got? We are going to have a high configured server. Instead of one operating system, multiple operating system is going to run, like, by using an option called virtualization. So what this virtualization will do, basically this virtualization is going to convert this physical hardware as a virtual hardware, and, like, by using software's hypervisor like a ESXi, KVM, or Hyper-V, and Zen hypervisor and Nitro hypervisor. So we have these all types of hypervisors we are going to add in this layer. Then on top of this OS, we are going to deploy our application and we are going to deliver. So in this layer, we wasted a lot of resource. But in this layer, okay, we have reduced this hardware we are using effectively, but this operating system also is going to take or consume some resources. Can't we eliminate this operating system to deliver our application? When this question rises, then this containerization mechanism came to the scenario. We are going to have the hardware. On top of that, one small application called Docker engine, it is going to run. Everything application is going to delivered here. So you are eliminating this particular operating system layer where that is going to consume most of your underlying hardware resource. So at that scenario, we got this, right? So virtualization versus containerization, that mechanism we call it as a containerization. This is an comparison. In this layer, we have infrastructure, we're using hypervisor. See this guest operating system, how much resource it is taking. On top of that, binaries and libraries and application 1, application 2, multiple applications are running here. But here, infrastructure, a small operating system is going to run, container engine is running. So this container engine is going to eliminate this guest operating system mechanism. So these two got converted to operating system and container engine. So the resource wastage got reduced. The resource wastage got reduced here. Okay, so this mechanism. So you can take one EC2 instance and you can deliver multiple versions of applications from that, EC2 instance. The main motto or mechanism is use the resource effectively. Whatever the underlying resource we have, we want to use at most or completely, we want to utilize this, right? So now we can go and we can launch that container service. So here you can find containers. Oh, Red Hat OpenShift also came to AWS. This is also container mechanism that owned by Red Hat. So now it is proprietary mechanism of IBM actually. So let's navigate to container service, ECS, that is Amazon own service. So we can create our own cluster here. We can create our own cluster and we can deliver that. So whatever you want to. So basically in this mechanism, in this ECS mechanism, so the first thing is task definition, the primary resources. So task definition is going to contain what configuration, what need to deploy, where it need to deploy, all the settings we are going to prepare under this task definition that we can deploy into clusters. Okay, so for that you can manually go here, you can create a task definition first. So these are some sample task definitions. These are some sample task definitions. You can go and you can create. Otherwise you can pick a sample, like default one, and you can, this is a default one everyone will get. So first run task definition. So here this is going to contain, like this is a task definition. In what network mode it is going to run? It is compatible with EC2 mode and Fargate mode. So you can take an EC2 instance and you can run within this application within that EC2 instance. Or Amazon serverless mechanism is Fargate. You can use that one also. So it is going to use a role, and to run this function, this is going to run Nginx. So to run this Nginx server, how much memory you want to allocate for that particular task? So if you are running two tasks, it is going to into two. Like for every single task, it is going to utilize 512 MB memory, 256 CPU count. It is going to use here. Then these are the services it is going to use. So similarly, we can even create our own task definition. Create new task definition. Which mechanism you want to go with? So this task definition should support Fargate only. Then pick Fargate. So this mechanism should support EC2. Then go and pick EC2 also. So I'm going to pick Fargate. Scroll down, click on next. Now, what is the name you want to give? ASDF is the name I'm giving. So this role it is going to create automatically. ECS task execution role is going to create automatically. Give that. Networking mode, go with the AWS VPC. This also picks automatically. Now, what container you want to run? What image you want to run? So basically, we have an option called Docker Hub. Whenever you go to this Docker Hub, there are many official images available, n number of. These all are the n number of images. What you required, you can go and pick. For example, I want to run Nginx. Go and pick. So this is a Nginx. So now this is the name. This name is important for us. So what tag you want to give? So you can pick any of the particular version. You can give Nginx colon latest or Nginx colon 1 or Nginx colon 1.19. You can give anything. If you want to go with this particular version, Nginx colon Perl, you can give that one also. So we always go with the latest, right? So this name Nginx colon latest. So it is going to pick this Docker official image from this Docker Hub. It is going to run. So while running, how much memory you want to give, that we can define here. So I'm going to give 512 MB and 256 virtual CPU. To what? To this particular container. What is the container name? Test container. What is the image? Nginx colon latest. So this is the image it is going to pick from the internet. It is going to use this particular resource, and later on we can deploy this. So now I'm creating this, right? One task definition got created. So as a phase one, we created task definition where you are going to deploy this task definition, right? In a cluster. So go to clusters, click on create cluster. Now, so what mechanism you want to go with? Networking only, EC2 Linux is going to pick automatical and networking. So I'm going like, so with Linux plus networking. Then click on next. Now, what is a cluster name? ASDF is a cluster name. So you can even create an empty cluster. So you want to go with the on demand? Yes, on demand. What is the instant type you want to? So you can go and you can choose a configuration here, right? So T3 micro, I'm going to pick how many instances you require. What is the AMI ID? So once your instance is ready, then you can run the task within the DC2 instance, right? So that is a mechanism. So otherwise, we can go here, get started. Okay, I'm looking for Fargate mechanism. Okay, let me go and pick this. Click on next. P3 micro, one instance, Amazon Linux 2 AMI, 30 gigs, and keypad AWS 730. And I'm going to create a new VPC with new security group. Port number IT is open for everyone. That is important. Then create. So now one ECS instance, ECS cluster is going to run in backend. So within that, we can run our task definition, whatever the task definition you want to run, the one created. So we can run the task definition. So then that Nginx image is going to download from the internet and it is going to deliver. So within one EC2 instance, we can run multiple tasks. Within this EC2 instance, we can run multiple tasks. How many tasks you are running, those many websites it's going to deliver. So if you are just going with EC2 mechanism, one EC2 instance, one application. If you want to deploy multiple at application level, we need to, or OS level, we need to perform some modifications. But here, nothing like that. Create a task and deliver it. Create a task and deliver it. So that is an advantage here with this containerization mechanism. So in this containerization, so Google developed another mechanism called Kubernetes. K8 or Kubernetes, right? So that Kubernetes is like, bit famous and it's gaining bit uh, major market share nowadays. So if you're really interested, so please spare some time and I can suggest you to learn that Kubernetes also, right? So here one cluster got created. This is a cluster. So now within this cluster, we can deploy the service or we can run the task. So I'm going to run a task. So now for this, what task definition you want to pick? I want to pick this particular task definition, the one we created some time back. How many tasks you required? One task. What networking? It is going to use the existing VPC and deploy. So now whatever the one we created some time back, that task definition is using to run this particular task. So it is happening here. So then it tells us, so whether it got deployed or not, what is the task definition is used and how much resource it is using here and what IP address you want to. So here under networking, we can see this is a public IP address we got for this particular task. So within this cluster, I'm running a task. So this task is going to contain an IP address, public IP address. By using this public IP address, we can access the Nginx output. So if everything goes well, we should get that output. It's in running state. The task is in running state. Now, if we go here, give a refresh. Not delivering. So if you want to test it locally, you can use this private IP address. You can launch one of the EC2 instance, and within that EC2 instance, you can give this private IP address. So it's going to show you that Nginx server IP address. Seems there is an issue with the public facing one. And what exactly happening back, and it is going to show us what configuration we have used. So similarly, I want to use this cluster to run another task. So I can go here, I can go to tasks, I can create another task, run new task. So then I'm going to use the same task definition and public IP address is enabled. Oh, it is using a default security group that need to be modified. Seems that is the issue. That's why it is not running. So here is a network. So it is running with the default security group. Right, let me create a new task here. I'm going to create a new task, run new task, picking the same task definition under networking. So I'm going to choose Linux SC, then scroll down, deploy. So now one EC2 instance is using for multiple tasks. So existing task I can stop. Why? Because that is not valid anymore. Stop selected. So the reason is I have used the default security group. That is the reason I'm not able to show the output. I am assuming that might be the reason. So now another task is creating here. It's in running state. It's in running state. So now navigate to networking. This is the public IP address. Grab the public IP address. Get that here. Seems that is not the issue. Something at application level. Now I picked the wrong one. Pick the previous one only. See this? We are able to get the output. So this particular task, see within this cluster, one Nginx server is running. So the only advantage is this Nginx server is using quarter of one CPU, 512 MB of the RAM. If you want to create another task, if you want to use this cluster very effectively, go here, run another task, run new task. What is the task definition you want to? I'm going to pick same task definition, and here in what VPC you want to run, what is the security group it is going to pick. So then deploy. So now the same EC2 instance is using to run the two tasks. How small? The T2 medium, T3 medium. So it comes with one virtual CPU, like um, 1 gigs of the RAM capacity, but it is going to use effectively. It is going to deliver, right? So that is a mechanism. See, both are up and running. Now for that another one also we are going to get a public IP address. That public IP address also is going to deliver the Nginx. See, this is different one, this is different one. So from where both are delivering? Both are delivering from the same this cluster only. Whatever the cluster we created. So both are delivering two running tasks within the server. So similarly, take a high configured server, run multiple applications, multiple tasks from that server. So we are effectively using this particular server, right? So that is a containerization mechanism. So if you want to learn containers, I can suggest you one website, that is containers from the couch. So this is the containers from couch. It is redirecting to YouTube. Okay, this is from official AWS. I personally suggest you to go with this. They will explain you what is containers, how the mechanism and all. You can go to playlist and you can see what is ECS, how ECS is going to work, what is EKS or Kubernetes. Go and learn that. So these all are the ones for ECS. So target mechanism, how it is going to work, everything, right? So that's my personal suggestion, right? So where is the delete option? Okay. Here is a cluster. Here is a delete option. In previous console, I know. In latest console, need to verify. So I'm going to delete this. Right. So I have another thing. ECS workshop. I can suggest you to go through this ECS workshop also to understand this. Right. So with this topic we have done with CACD and another one. So tomorrow I'm going to explain what is AWS organizations and how you can manage multiple accounts from one, one AWS account. For that I need someone who can voluntarily share their account details, and I want someone to share their screen. So then only I can. Why? Because just for that I cannot create another account, and that is bit important also. So please someone um, share your details so that we will perform tomorrow, right? So I'm going to share quiz 3 document also in our today's session, in our Slack channel. Please spare some time and go through that, guys. Right? So that's it for today's session. So if you have any questions, please post in our Slack channel. I'm always open to your questions. Right? So see you again tomorrow. Thank you, guys.